Okay, in this first one about the differential, we're going to show how to use the differential to estimate a function change. Now, remember what our formula for the differential looks like normally is we usually like to write down that df equals fx dx plus fy dy. When you start taking differential geometry, that'll mean one thing, but what it means actually to most scientists is that the change in the function value, so it's d to delta, right, is approximately equal to fx delta x plus fy delta y. And just a reminder that this last part here just came from the change in the values on a tangent plane. Now, what do we need to do here? I need fx, I need delta x, I need fy, I need delta y, and then we just need to plug in. So let's start doing stuff. Fx, I guess I want to tend to, right? The derivative with respect to x is 1 over y. When I plug in 10 to, I get a half, like that. Fy at 10 to, I'm going to take the derivative with respect to y. I'm going to get minus x over y squared at 10 to. That's going to be minus 10 over 4. That's going to be, I'm going to get right at it as minus 2.5. I'm avoiding the fractions if I can do it. Let's see here. What's delta x? Delta x. Well, delta x went from 10 to 9.98, right? So that's going to be negative 0.02. Delta y. Y went from 2 to 2.05, so that's 0.05 like this. And now we're just going to plug in the numbers. Plugging in the numbers, fx is a half. Delta x is minus 0.02. Fy is 0.05. Like that. Fy is 0.05. Let's see here. Wait. Fy is minus 2.5. And we're supposed to multiply that by delta y, which is 0.05, like that. So hold on a second, let's just wall ourselves off a little bit here. So I'm going to get something like minus 0.01 minus, let's see here, that's half. I'm thinking it's minus 0.125. Yes, I think that's minus 0.125. I think. And this is going to be minus 0.225. By the way, f of 10 2 is just 5, so I'm thinking this is going to say something like 9.98 over 2.05 is like 4.775 or some such. But meanwhile, if we remember the formula for the differential, remember that that actually just comes from standing on a plane and saying, how do you change function values from one point on the plane to the other, and we just use this. This is exactly the way this gets used.